Okay, question 1. ABCD is a trapezium. We're given some lengths here, and the angle ABC and BCD are both 90 degrees, so that's these two down here. It says calculate the size of angle CDA. So CDA would be this path like this. So of course the angle we're looking at is this one here. Now that kind of gives me an idea of what we need to do already, because if we look at angle CDA here, that's obviously what we need to find, but we can't just say what value it is. But it does give us a good indicator about where we need to perhaps cut the shape. So if I look at cutting this shape like so, we've now got a triangle and a rectangle. So if I take this triangle out down here, draw it like so, this angle down here is obviously the one we need to find, so we can call that X. We've then got a base, which is this 24, so I'll write 24 here. And we've also got a height. Now the height, 25, is responsible for the entire height, so let's not forget we've got 10 here. So of course 25 take away 10 will give us 15. Okay. Now if we've got a right angle triangle, we've got two lengths, and we need to find the angle. It will be trigonometry. So if we remember Quartile, and before we dive into that, let's not forget angle opposite. The side opposite a right angle will be the hypotenuse. The angle we're trying to find is this X here. So of course the side opposite to that angle will be here, and this would be the adjacent. So scanning through Quartile, we look at what we have. We have the opposite, so I'm going to tick the O. So it's either going to be sine or tan. And then we look at what else we have. We have the adjacent here, so I'm going to tick the adjacent. Now there's this one too. So the one that we have 2 ticks for out of the 3 is the one we select. So it means to find X here, we're going to use Tamp. So then I'll write down here tan equals opposite over adjacent. And of course that should be tan X. And then we can fill this in. So tan X equals the opposite value, so 15 over 24. Then to get X by itself for the angle, we do tan minus 1, 15 over 24. And if we put that into the calculator now, remember to close the bracket, we get X equals 32.00538321. So we could say that is X equals 32. Okay. And then of course that is for, we can show this angle here. So if this angle here is 32, let's not forget that we have a right angle here. So we're going to have 90 plus 32, which is 122 degrees. So we could then finish it off with, therefore, CDA, angle CDA equals 122 degrees. And it does say to 3 significant figures. So of course, even if we did add this long figure here, we would still have got 122 with the decimals. Okay, and obviously 3 significant figures, 1, 2, 3, it would be this one here. Look at the number to the right, that's 0, so therefore it would have stayed as 122 degrees. And that's your final answer. Right, question 2. We're looking at the Paralympic Games, gold and silver medals, gold and silver. The total was 35. The ratio of the number of gold to the number of silver was 3:2. So we've got gold to silver 3:2, and we've got a total of 35. So with the ratio, no matter how easy it is, I always recommend that you do this. Draw a box. We've got this representing the total amount. In this case, it's 35. And then we've got 3 gold, so 1, 2, and 3, and 2 silver. So I'll just fill that in: gold, 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 silver, silver, and that represents 35. So we've got 5 boxes in total, so some of you will be used to seeing the 3 plus 2 equals 5 and then just quickly doing it, but this is kind of how you understand what's actually going on. So we've got a total of 35 divided by a total of 5 parts here, so 35 divided by 5, and that would give us 7. So that means 1 part equals 7. Now if we know that 1 part equals 7, we're asked to find how many silver medals, so that would just be 7 times 2, which is 14. So you can write 14 silver, just to clear that up. Okay, and it's quite important that you do this and you show the representation with a drawing, because it will help when the ratio problems could be a lot more difficult than this. So try not to jump in straight ahead, with a quick, all you do is you add the ratios up, divide by the number. Okay, it's a bit parrot fashion. Try and understand what's going on, and therefore when it gets to the harder questions involving ratio, you can use the drawing technique and it will probably help you out with most of the question. Okay, so a camera needs to be purchased for question 3. This is a camera needs to be purchased in France. The camera costs €126, and in America $165.24. The exchange rates are given. We need to find out how much cheaper in America than in France is the camera. So it says here give your answer in pounds. So we've got France here and USA here. Okay, so with these kind of questions, it's always good to lay out as neatly as possible. So we've got in France is €126. Okay, and we have the conversion here where €1 equals 0.89 or 89p. So we know that we have €126. Okay, and that equals, well, we don't know how many pounds. So the question you need to ask yourself is, how do we go from €1 to 126? Well, we times by 126. So that gives us the answer to what we need to do here. We need to do 0.89 times 126. So if we do that, we get £112.14. So 112.14. Okay, so that's in pounds. If we now switch over to the USA, we have the price first. This is that like we did with the other one, $165.24. Okay. We also have the exchange rate, so we have £1 equals $1.62. Now what you'll notice is you're probably thinking, oh, I know what I need to do. I just need to put an arrow here like this, if I copy the other one, and then write 165.24. Okay, now here's the problem. This is not in a unit currency, and what that means is not to the value of 1. So before we can just do this part and just say, oh, it's times 165.24, we need to get this value to 1. So if I just remove that for now, before I write $165, I need to write $1. Okay, $1. So now you ask yourself the question, how do you get from $1 to 162 or $1.62? Or what would go into $1.62 to give you an answer of 1? And the answer is you would divide by 162. So if you divide by 162 on that side, you do the same here. Okay, and let's just put the divide symbol. So if we now do £1 divided by 1.62, you get 0.617. Okay, etc., equals $1. Now this is where I'm going to use the answer function on the calculator. So as a fraction, I get for 0.617, I get 50 over 81 in terms of money, but obviously that doesn't make much sense. But your answer is 0.61, etc., etc. So what I'm going to do now is go to my right hand side. I need to times this to get 162. Sorry, 165.24. Okay, what do I need to do to $1? Well, I need to times that by 165.24. So now on the calculator, I'm going to push on, then I'm going to press answer times 165.24. And once I do that, I get an answer here of £102. And then once I've done that, I'm going to clarify this. So France, it costs, or it comes to a total of 112.14, and USA, it comes to £102. Now we're not done yet, because it does say how much cheaper is it in America. So then we do 112.14, take away 102, do that in the calculator, and we get an answer of £10.14. So it's £10.14 cheaper in USA than France. It's always good to summarize your answer like that, just to make sure you fully covered every single angle, and you'll get your full marks for that question. So hopefully that wasn't too confusing. Some of you may have not seen that before. Try not to stick to the, oh, you either times by or divide by it. That's a 50-50 chance. So if you're sitting in the exam and you're thinking, well, it's either times or divide, you're just gambling. You're just thinking, okay, what one is it? Try and actually work out what it is you're doing. What you need to remember is when you have the unit conversion, which is when you have it like this, so $1, then it's very easy to just say, oh, all you do is times by this. When you don't have it, like we didn't for the USA, you have to do an extra step. So you have to get it to the unit conversion first. But you see when we had it for the euro, it was quite simple. We just had to do this times by 126, and we got our answer straight away. Okay, so just watch out for that. And then you'll be able to do those questions. Okay, question 4. A group of 200 adults were asked which types of magazine they read, and then we have a whole list of replies. Complete the Venn diagram for this information. So you can see we've got sports, garden, and fashion, and then the whole host of information. So what we're going to do is start from the inside and work our way out. So you can see our last point here is 14 read sports, garden, and fashion. So the point where all three of those intersect is in the centre here. So we know that this for sure is 14. And now once we've worked that out, we can now isolate it to just the two. So what I mean by that, and what you need to do as you're doing this question, is really try and visualize just two of the circles. So for example, if I select the sports and the fashion, I can then look at which two intersect for here. So sports and fashion, if I look at where that is, it says that there are 31. Okay, so if this 14 didn't exist, I would just write 31 here. But the 14 does exist. So what I need to do is do 31 take away 14, and that will give me 17. So instead of me writing 31 there, I'm going to write 17. And that's that section complete. Next, I'm going to look at this section, so the garden and the sports. So if I look at the garden and the sports, the garden is, sorry, the sports and the garden, it reads here, there are 36. So again, if 14 didn't exist, I would just write 36 like that. Okay, but the 14 does exist, so I need to do 36, take away 14, and that gives me an answer of 22. So again, just remove these and write 22 here. And then I'm going to focus on the garden. And the fashion for this intersection point here. So if I look at garden and fashion, it says there are a total of 25, and I've got the 14, so if I didn't have it I would write 25 here, but I have that 14, so then I need to do 25, take away 14, which gives me 11. Okay, now some of you are probably thinking, well, why do you type that in a calculator? Well, it's quite easy. Whatever you do in a calculator paper, please do not get the incorrect answer because you think you're too good for a simple calculation like that. You've got a calculator there, use it. And then for the last few stages, we've got the very initial point. So for sports, for example, take this circle here, it says that 82 read sports magazines. So 82 would fit in all of this. But of course, we've got these three other sections here. So what we need to do is 82 take away all of those sections. So if I use the calculator now, 82 take away 22, take away 17, take away 14, that gives me a total of 29. And then I do that for the other circles. So for garden, there should be 80. Okay, so we've got the other intersection, so we do 80, take away 22, take away 14, take away 11. That gives us 33. And then for the last section, the fashion, which is here, there are 84. So then we do 84, take away 17, take away 14, take away 11, and that gives us 42. Okay. Okay, and if we now add all the numbers up together, so if we do that in a calculator, 29 plus 17 plus 14 plus 22 plus 33 plus 11 plus 42, we get 168. And at the beginning it says there are 200 adults, so therefore 200 take away 168 will give us 32. So 32 would be on the outside here. So if we now look at part B, one of the adults asked is to be chosen at random. Find the probability that the adult reads none of these magazine types. Well, it's not going to be anyone in here because these are all the magazine types, so it has to be this 32 here. So it's going to be any probability 32 out of the potential total, so 32 out of 200. And part 2 of B reads exactly 2 of these magazine types. So now we need to focus on the areas where at least 2 of these are chosen. So it wouldn't be this number here, this 14, because that would be all 3 are chosen. So we need to work our way around the Venn diagram now. So we need to look at the points where there is only 2 intersections. Well, that would be this number here, this number here, and this number here. Okay, so then we would do 17 plus 22 plus 11. So if we do that in the calculator, we get 50, and therefore it would be 50 over 200 as our probability. Right, question 5. Here's a prism. ABCDF is the cross section of the prism. ABCF is a square of side 12. FCD is a trapezium, and ED is 22. The height is 20, and the length of the prism is 80. Work out the total volume. So, volume of a prism, okay, is cross-sectional area, so CSA, times the depth. Okay, so cross-sectional area would be, like it says, this grey part here. So this part and this part, and then you just times it by the depth of the shape. Okay, so the fact that there are two shapes here, so a square and a trapezium, means we've got compound area, so we're going to treat it as 2D initially, and then of course it will make it volume or 3D when we times by this depth here of 80 centimeters. Now you do need to make sure before you start calculating that all the units are the same, and from looking at this question everything is in centimeters, so we don't have any unit conversion required here, but we do need to work out the area of each shape first. So I'm going to call this shape 1 and this shape 2. It says that this is a square, so I'm just going to write 12 centimeters there. So writing 1 here and then just drawing a rough sketch, I've got 12 and 12. So therefore the area of this is going to be 12 times 12, which equals 144 centimeters squared. So I've done the square. Next up we have a trapezium, and you're going to need to remember the formula for a trapezium, which is area equals half sum of parallel sides. I'm just going to write sum of parallel times the height between them. So we look at where the parallel sides are. It is not these two, so if you remember what parallel means, they will never touch, and of course if you carried on drawing these lines you can see they intersect right here. So the parallel lines are indeed the F to C, so the 12 and the 22. Now by definition sum means to add, so therefore we're going to have A equals half and then sum of the parallel sides. So it doesn't matter which order you do it in, but 12 plus 22 in this case times the height between them. So it's not as easy as you might initially think, but then we've got a square on top, so it's not all that difficult. We need to find out the height between these two parallel sides. Well, if this is 20 in total and we've got a square of 12, to find that it's just going to be 20 take away 12, which is 8. So our height is 8 centimeters. So then you can put all of that into your calculator, and don't forget the brackets. 12 plus 22 times 8, and then you get an answer of 136 centimeters squared. So that's for area 2. So we've got area 1 and area 2. So this is CSA, cross-sectional area, is going to be 136 centimeters squared plus 144 centimeters squared to give us a grand total of 280 centimeters squared. Okay, now it wants the volume, so we get our CSA times depth. So we've got our CSA, cross-sectional area, is 280 times depth of 80 centimeters, and then we get a total of 22,400 centimeters cubed. Okay, because it's volume, and that will be our total answer, our final answer. That's for 5 marks. So this kind of question, they haven't asked for any unit conversion, but what we can expect to see is unit conversion required, and it will sometimes be the depth here, or it could be any one of these measurements really, but don't slip up and miss that out. Fairly easy to do. So just make sure before you start, oh, I've seen this on this video, if this comes up in the exam, don't dive in straight away trying to get this question done as quick as you can. Slow yourself down, have a look at everything, make sure there's no unit conversion required. If there is, decide whether it's wise to do it at the beginning or the end. I'd recommend doing it at the beginning, and then you want the least work possible, so convert with the least work required. But yeah, so that's how you do these kind of questions with volume. Okay, question 6. Liquid A has a density of 0.7 grams per centimeter cubed and liquid B has a density of 1.6 grams per centimeter cubed. So just reading that alone, I should be thinking, right, density equals mass over volume. Now I'm going to continue reading. 140 grams of liquid A and 128 grams of liquid B are mixed to make liquid C. Work out the density of liquid C. So liquid A and liquid B. So what do I know? I'm going to write density, mass, and volume. Same here, density, mass, and volume. Now looking at this, liquid A, I know the density is 0.7 grams per centimeter cubed, and for B, 0.6 grams per centimeter cubed. I know that liquid A has a mass of 140 grams, and liquid B has a mass of 128 grams. So for this liquid C, you should really write up here, but I'm just writing down here for space. For liquid C, it's still going to be density equals mass over volume. We need to find density, so that means we must have the mass and we must have the volume. So we've got the mass, so that would be 140 plus 128, which will give us 268 grams. Okay, but we don't have the volume yet. So we can work the volume out by using the density and mass, which requires a bit of rearranging. So to set this equation up that we've written up here, some of you use the triangle. If you like that, go ahead. This is just some basic algebra rearranging. So I need to get it to volume equals. Okay, so in order to do so, I need to look at what's happening, or how do I shift the volume. So currently it's mass divided by volume. So what I need to do is times both sides by volume. That means I will end up having volume times density equals mass. And I said I want volume equals, so I need to get rid of this times density, where the inverse of times is to divide. So therefore I'm going to have volume equals mass divided by density. And this equation I can now use for both liquid A and B. So the volume, I'm just going to write here the mass, 140, divided by 0.7. So V equals, again using the calculator, no point trying to be fancy and quick, we've got a volume of 200. I'm going to do the exact same here, so I've got 128 over 1.6. If I put that into the calculator, I get 80, so volume of 80. Okay, and this is in centimeter cube and centimeter cubed. So now to find the total volume, I just need to add these together. So total volume will just be 200 plus 80, which is 280. Again, no matter how easy the calculation is, make sure you write it. So now we've got our volume here of 280. So therefore, to find the density, we do 268 divided by 280, and if you do that into the calculator, you'll get 67 over 70, or 0.9571428,571 grams per centimeter cubed. Okay, and we could just write 0.957 as our final answer. Okay, question 7. A cumulative frequency graph gives information about the recorded speeds of 100 cars travelling along a road. So here's our cumulative frequency graph. It says the least recorded speed was 40, the greatest recorded speed was 87. On the grid, draw a box plot for the speed of these cars. So for a box plot, we need a few things. We need the lowest value, we need the lower quartile, we need the median, the upper quartile, and then the highest value. So we've been given the lowest and the highest, so let's just plot that now. So the lowest is 40, we can represent that with a line like so, and the highest is 87. So 85 would be here, 87 would be like so. Okay. Now, to find our lower quartile, well, lower quartile, or LQ, would be 1/4 of the amount. And it says 1/4 of 100. So that would be 25th car for the lower quartile. So finding the 25th car, that would be on the y-axis. So that's around here. So if we then go across and then down, that is roughly the 54 miles per hour. Again, this is roughly. On your exam, you'll be able to use a ruler and see a lot better. But from what I can see here, it's around 53 to 54. I'm going to go with 54. So that will be here. Okay. The upper quartile, I'll just write that up here, is 3/4 of the amount. So 3/4 of 100 is 75. So the 75th value. So if I then find 75, so 72, 4, it's going up in 2s, roughly here. Going across. And then once we've met that match, going all the way down, I get an approximate value of around 73. Let's just mark that as 73. While we're at it, I did mention this was incorrect value. I think I said 54. It's actually 52. So yeah, 52 there. So yeah, 73 for this one here. So 1, 2, 3. We're doing the same colour. 1, 2, 3. And it will go here like that. So looking at our checklist on the right, we've got our lower quartile done. We've got our upper quartile done. All that's left is the median. The median is the middle number. Okay, so half of amount again. So it's half of 100, which is obviously 50. So the 50th car in this case. So we find the number 50, which is here, and again, draw across, and then down. It's also good to write upper quartile, lower quartile, median here too. So if we look at where the median is, it's 61, 62, 63. So if we find 63 here for our box plot, is here. Now we have all the values, so what we can do is we can connect up our box plot. So lower quartile to upper quartile is going to be the actual box. Then we're going to have the whiskers on the end. So that shows the lowest value, the highest value, then this being the lower quartile, upper quartile, and median. Okay, and then that's that completed. Right, so if we look at question 8 now, Peter has £20,000 to invest in a savings account for 2 years. He finds information about 2 savings accounts. So we've got a bonus saver and a fixed rate. So the first bonus saver one gives you 4% for the first year and then 1.5% each year thereafter. And the fixed rate just gives 2.5% each year. Peter wants the most money as possible. So which one should he choose? So With percentages, we should remember immediately that it's out of 100%. Seeing as we're talking about interest and savings, then it's going to be added to it. So for those of you who use a multiplier technique, it's going to be 1.01, for example. We're not going to reduce. So with that out of the way, just as kind of a small introduction, let's write bonus saver here. So for the bonus saver, we've got our £20,000 that we have originally, and we're going to times that by the interest. So this, if you like, is going to be year 1. So it's going to be 100% plus 4% for the first year. So if I show all the working, it's going to be 20,000 times 104%. If we go back to basics and remember what the percentage sign means, that means over 100. Okay, so then I can write 20,000 times 104 over 100. Then of course that's where we get our multiplier from, because that's going to be 20,000 times 1.04. Okay, that gives us a total of 20,800. Now you need to be really careful here, and you need to make sure you read the question. If it asks after 1 year how much interest was gained, it's not 20,800. It would just be £800. Okay, so just be very careful of what is being asked and what it is you're actually working out. And of course, if you just wanted to work out the answer straight away, you could have done 4% of 20,000, and that would have given you £800. But let's just not go too far off track. So in year 1, there was 20,800. Now year 2, you get, and every year after, you get 1.5% each year. So this is going to now be 20,800 times the 100%, because our 20,800 is now the original 100%, plus 1.5%. So 20,800 times 101.5%, that makes it 20,800 times 1.015 to give us a total of £21,112. Okay, so that's with the bonus saver account. Now if we look at our fixed rate, we get 2.5% each year. So we can do this in 2 ways. We can do it exactly like we did the bonus saver. So we can do, and I'll show you both ways just so you can choose. So if we do year 1, 20,000 times 100 plus 2.5%. I'll just speed this up now because I'm sure you've got the idea. Times 1.025. If we now do that in our calculator, 20,000 times 1.025, we get 20,500. That's for year 1. So for year 2, we get 20,500 times 1.025 again, which gives us 21,012.50. Okay, so if I just like so in year 2 with the fixed rate, we get £21,000 and £12.50. And for the bonus saver, we get £21,000 112. So obviously the bonus saver is the one that we want to go with. So let me just finish this off by showing you the different technique, or the formula, which some of you may remember. And because it's compound interest and the rate is the same, we can simply do 20,000 times 1.025 to the power of 2. So to the power of being the number of years, we're looking at 2 years, so we can just do that. Now the reason for that is because I have multiplied by 1.025 once, so hence the power to the 1, and twice to the power of 2. Okay. One thing I would strongly suggest in the exam, please remember to do this. 100% plus 2.5%. Really go through it. So 102.5%. Do that in a calculator. So that's 102.5 divided by 100, and make sure you get the multiplier correct. So that gives us 1.025. Please do not mess this up and write 1.25. Okay, because that is not 2.5%. That is plus 25%. Okay, so very easy mistake, but will make you get the entire answer incorrect. So just watch out for that. And of course, if you did this, you would get £12,012.50. And of course, don't forget to stay bonus saver account to be used, or something along those lines. Okay, question 9. Rachel walks to school. The distance to school is 2.8 kilometers, rounded to the nearest 0.1 kilometer. She walks at a speed of 5 kilometers per hour, correct to the nearest kilometer per hour. Calculate the upper bound in minutes for the time Rachel takes to walk to school. So let's start off first with the distance. The distance is listed as 2.8 kilometers to the nearest 0.1 kilometer per hour. And then we have the speed, which is 5 kilometers per hour to the nearest kilometer per hour. So we've got a situation where we need to look at the bounds. So in this case, what we need to look at is the potential numbers that we could have, and we'd end up rounding to 2.8. So we need to look at a number below 2.8 and a number above 2.8. So seeing as we're looking to the nearest 0.1, we're going to have probably 2.7 kilometers per hour. Well, let me just remove the units for now. So I have 2.7, the 2.8, and the 2.9. So now what we need to do is we need to look at this range and what numbers would we get in order for us to round down. So what's the highest number that it could be, or the highest boundary, and this is the very clear difference that hopefully I should be able to clear up with this question. This is a boundary, so what's the absolute max limit this number could be? So if it's rounded to 2.8, the upper boundary is obviously going to be here. Okay, somewhere in this section. So what's the highest possible number that this number could be before, so that it rounds to 2.8? Well, that would be 2.85. Now, a lot of you are probably thinking, well, 2.85, if you got that, you would round it to 2.9. Yes, you're correct, because you are looking at the 5 here. But we're talking about boundaries here. So if you imagine this as a wall, okay, this is a wall, 2.85, if I can just get rid of that, 2.85 is the wall itself. So technically speaking, the number that's right here could be 2.849999. Okay, the wall itself is 2.85. Therefore, our upper boundary for the distance is 2.85. And now, if we look at the speed in the same way, the speed being 5, so we have 5 here. This is now to the nearest 1 kilometer per hour. So we're going to have 6 here and 4 here. Now, we need to calculate the upper bound of time taken. So, in other words, how could we work out the longest time taken? Well, it would be the, so if I just write time here, Okay, not in any formula, just here. The time, how can we make it take the longest? Well, that would be the largest distance. Okay, so we've got the biggest distance and then the slowest speed. Because if we've got a really large distance and a really slow speed, that's going to be the absolutely most time that could be taken. So our largest distance would be the upper bound, which we've already calculated as 2.85. We now need to work out the slowest potential speed that this could be. So this number here is rounded to the next 1 kilometer per hour. So if I just write that out and put that here. Okay, so if we've got the answer of 5, what could the lowest bound for that number be? So that would be this number here, which would be 4.5. So in this case, it kind of makes sense. It's kind of intuitive that, oh yeah, there's no argument there. If you got 4.5 as your lowest boundary, if you got that number, you would automatically round up to the 5. Whereas with the upper bound, we saw something different. So with the lower bound, a boundary of 4.5 is valid. So, and it kind of makes sense. Whereas with the upper bound, there is that confusion that hopefully I've kind of cleared up for most of you that had that. So 4.5, if we got that as a number, it would round to the number we have, 5. So therefore our lower bound for speed is 4.5. Now we're talking about speed, distance and time. So what we need to use now is a speed, distance and time formula. So if you remember, speed equals distance over time. That's our formula. We need to work out the time. So rearranging this would get time equals distance over speed as the formula to use. Now before we go ahead and start putting numbers in, we do need to be aware of what we're being asked. So it says calculate the upper bound in minutes. So if I'm going to put time equals the distance, 2.85, over 4.5 and get an answer, I need to be aware that I'm working with kilometers and kilometers per hour. So my answer in time is going to be in hours. So if I now do that into the calculator, 2.85 divided by 4.5, I get t equals 0.63 recurring. Okay, and that is 0.63 recurring of an hour. So for me to get that into minutes, I need to do 0.63 recurring times 60 minutes. Okay, and that will give me my answer in terms of minutes. Now, to use this the most accurate, I use the answer function. So once you've got your 0.63 recurring in your calculator, push on, push the answer button, and then put times 60 and push equals, and you get an exact answer of 38 minutes. Okay, now doing that question, if you're confused with it, try and have a look at see if you can find any more lower and upper bound questions. But I do know that they can be quite tricky to get your head around, but once you have kind of got your head around it, it kind of makes sense. Also for the time, it says upper bound. What a lot of people do is they will choose the upper bound for both distance and time, and speed. You just need to stop for a second and think, right, okay, if this was you now, how would it take the longest time possible? Well, it would be the greatest distance at the slowest speed, wouldn't it? So just something to think about with the lower bound, upper bound questions. And hopefully I've helped, not confused you. Okay, and for question 10, there are 30 tennis players in a tennis club. 2 players are selected at random to play a tennis match. How many different combinations of players could be selected? So we see this word here called combinations. Now on your calculator you may have not seen this before, but it's called the N choose R. Okay, it's this button here. Now my Casio calculator is just underneath the AC button. Okay, and the R is the objects, and n is the total amount. So how we'd use this here would be to put, we would like to choose from 30 objects, or in this case players, 30 objects or players, choose 2. Okay, so we push the shift and then the divide button, which will give us the C. So we type in the number 30 first, push shift, divide to give us the letter C, and 2, and then press equals. And we get an answer of 435. So there are 435 combinations of players that could be selected for this tennis club. Okay, question 11. RT are points in a circle, centre O. ROP is a straight line, PT is a tangent to the circle, angle TPO is 46. Explain why angle OTP is 90 degrees. Okay, so writing that here, this is for 1 mark. We can write angle, and this is talking about here, angle OTP. So this angle here. Okay, here's our radius. Okay, and the tangent is here. Okay, and the reason why it's 90 degrees is because the tangent meets the radius at 90 degrees. Okay, part B. Work out the size of angle Y. Right, so looking at this, if we know that this angle here is 90 degrees, we can work out this angle here. So what I'm going to do is I'm going to write angle POT is going to be 180, take away 90, take away 46, and that's going to give us 44 degrees. So angle POT is 44 degrees. Now, I can see that this point here is centre O, and it does say that it's the centre. So if this is the centre, I can say that this is a radius, and this here is a radius. So what do I know about this? Well, if these two lengths here are the radius, that means that angle Y here is going to be exactly the same value as this here. So I've got an isosceles triangle. So what I can do first is work out this angle here, and then subtract that blue angle away from 180 and divide it by 2. So let me just write that down. So angle ROT is going to be 180, and this, don't forget, is 44. Take away 44, which is 136, and don't forget angles on a straight line. So it's 136 degrees there for angle ROT. Okay. Then to find Y, so Y is angle ORT. Well, that's going to be 180 take away 136, which equals 44. And then we could put over here 44 divided by 2 equals 22 degrees, and then put in brackets isosceles triangle. So we know the angle ORT equals 22 degrees, or Y equals 22 degrees, and that's our final answer. Okay, question 12. Use algebra to show that the recurring decimal 0.38 is equal to 7/18. So 0.38, let's actually write what that means. It means 8, 8, 8, 8, 8, and so on. So our objective is to get rid of the recurring part. So what we can do is we can say x equals 0.38 recurring. Next, we can try timesing it by 10, so that would be 10x equals 3.8 recurring. Now I need to get rid of this section here. I can't do 10x take away x because I've got this 3 in the way. So if I multiply this once more to give me 100x, I will then get 38.8 and so on. So I can now do 100x equals 38.8, 10x equals 3.8. If I take those away, I'm going to get 90x equals, if I do 38.8 take away 3.8, I'm going to get 35. To get x by itself, I divide by 90. So x equals 35 over 90. And if I put that into my calculator, I get 7/18. And there we have shown that we get 7/18. So with this section right here, you need to manipulate it. The biggest tip I would say is doing this here, because establishing what the number actually means gives you a rough idea of how far you need to go, and you don't have to go too far with this one. Some of them can be quite difficult, and it just means you might have to go to 1000x, but just be aware of what it is you're doing. Don't start going to 10,000 or 100,000x. Start having a look and seeing if you can make it easy for yourself. Right, question 13. Work out the formula for the nth term of a quadratic sequence. So looking here, we have these differences here, and this is going to be here a first difference. Now they've told us it's quadratic, so therefore we can expect there to be a second difference, and this should then stay constant. So to get from 11 to 19, we add 8. 19 to 29 plus 10, and then from 29 to 41 plus 12. So to get from 8 to 10, we add 2. 10 to 12, we add 2. So if our second difference is 2, that means 2n squared divided by 2. We divide by 2 because it's the second difference. That means we have our first part as n squared. Now if we remember from a standard quadratic, we have ax squared plus bx plus c. Typically for a sequence, you'll see an squared plus bn plus c. So at the moment we have our an squared part, which is just 1n squared, but we need to find the bn plus c part. So what I'm going to do now is the simultaneous equation method. There is a different method to this, but I prefer this method overall. So what I'm going to do quickly is label each one of these terms. So this is term 1, term 2, term 3, and term 4. So for equation 1, I'm just going to write EQ1. Okay, I'm going to write an squared plus bn plus c equals, and then what it equals, so 11. So I'm going to have n squared plus bn plus c equals 11. And now if I substitute that in, so I'm talking about the first term, that means I'm going to make n 1. So it's going to be 1 squared, which is 1, plus bn, well b times 1 will just give me b, and then plus c equals, there should be another one there, equals 11. So for equation 1, I have 1 plus b plus c equals 11. So if I just sort that out, I have b plus c equals 10. So that's my first equation. I'm then going to do exactly the same thing and make an equation 2. Why? Because I've got two variables. So if I then do an squared plus bn plus c equals, I'm going to go for term 2 this time, so my answer there is 19. I'm then going to do exactly the same. So I know that the beginning is 1n squared, so I'm going to make that n squared plus bn plus c equals 19. And now here's where I substitute in again. So this time I'm using the 19 value, which happens to be the second value. So I'm going to make n 2. So if I do 2 squared, that's going to be 4, plus b times 2, which is 2b, plus c equals 19. So if I get rid of the 4, I'm going to take that away. So I'm going to end up with 2b plus c equals 19 take away 4, which will give me 15. And here is my second equation. Now I can use this equation here and this equation here as two simultaneous equations. So just writing that down here, I'm going to have b plus c equals 10 and 2b plus c equals 15. So that's my equation 1 and my equation 2. Now from here I don't need to do any multiplication. I can just eliminate c straight away because I've got one c and another c. So if I've got a positive c and I take away from another positive c, that's going to eliminate the c. So what I can do here is take away. So take away, take away, take away. Then I've got b, take away 2b. Well, that's going to leave me with minus 1b, so minus b. The c's will cancel, and then 10 take away 15 will leave me with minus 5. I don't want a value of negative b, so I can times this by minus 1. So therefore I can make b equal to positive 5. So now that I know that the value of b is 5, I can substitute this 5 into either equation 1 or 2 to find c. So I'm going to put it into equation 1 because that's the easiest. So let me just write that out. That's b plus c equals 10. And then we know b is 5. So 5 plus c equals 10. And then we need to get c by itself, so take away the 5. So c also happens to be 5 as well. So we now have our an squared, our b, and our c value. So if I write an squared plus bn plus c, well, we know that this from the very beginning was 1n squared plus, we just worked this out, the b value, which is 5, so 5n, and we just worked out the c as well, which is 5, 2. And then here is our final quadratic formula for this sequence. And of course it's always wise to check, so I'm going to make n equal to 1. So I'm going to have 1, and then 1 squared is 1, so this will be 1. 5 times 1 is 5, and then we've got the plus 5. If I do this calculation, 1 plus 5 plus 5, we should get the answer of 11, and we do. There's no harm in trying for the second value as well, but I'll let you do that and trust that it is indeed correct. So that's obviously a slightly longer way of doing it, but if you're good with simultaneous equations, it's quite an easy way to do it as long as you can keep track of your workings. So really all we're doing is we're making one equation for the very first value here, and then another equation for the second value, and then using that value there to find the answer for b and c. So it looks slightly complicated if you used to the table technique, but I actually prefer it, and I think it's a lot better way of doing it. But again, choice is up to you. If you're good with simultaneous, it shouldn't be too difficult. Okay, question 14. L and M are two mathematically similar prisms. Prism L has a length of 8, M has a length of 20. L has a height of 3, so work out the height of prism M. So basically we need to go from L to M. Now we've got two values here, 8 to 20. So going across to increase would be timesing. So we need to work backwards to find the scale factor. So if we do 20 divided by 8, that's going to give us our first scale factor, which is 2.5. So we've got a 2.5 scale factor. So just to test this, if I now do 8 times 2.5, I should get 20. So let me just try this. 8 times 2.5, and I do indeed get that. So I know that the scale factor, and this is a linear scale factor by the way, because we're dealing with dimensions and it's centimeter to the 1. The linear scale factor is 2.5. So if the height of L is 3, that means I can do 3 times 2.5 to find the height of M. So if I do 3 times 2.5 now, I get a total of 7.5 centimeters there. Prism M has a volume of 1875 centimeter cubed. Work out the volume of prism L. So the larger one, M, has 1875. Right, so at the beginning I mentioned linear scale factor. So we know the linear scale factor is 2.5. We then have area scale factor and volume scale factor. So if we remember, this is centimeter to the 1, area is centimeter squared, and volume centimeter cubed. So even though we don't need the area scale factor, let's do that anyway. So that's going to be 2.5 squared, which is 6.25, and then the volume scale factor is 2.5 to the power of 3. Okay, don't cube the 6.25. So we're always dealing from the linear scale factor. So the volume scale factor is 15.625. Now, making sure we're doing this correctly, that was to get from L to M. So it's worth making this note. Okay, so to get from L to M, we had to multiply because we were increasing. Now we've been given the volume of L, so volume of M, and we need to get to volume of L. So we are going to be decreasing. So this time, instead of multiplying, we're going to be dividing by that. So we're going to do 1875, divide that by 15.625, and that will give the volume of L. So if we do that in our calculator, 1875 divided by 15.625, we get a volume of 120 centimeter to the power 3, or centimeter cubed. Okay, question 15. This table gives information about the times in minutes 346 children spent playing online games in 1 week. Draw a histogram for this information. So, histogram, we must remember that on the y-axis we have frequency, density, and then of course we have our time on the x-axis. So from a histogram, for example, we should have boxes like this. So if we think of the area, okay, of this box, the area, okay, we do frequency, density, let's just put FD, FD times time will give us the frequency. Okay, so if we can kind of get into that routine with these histograms, you don't really need to remember the formula. So just draw a quick rectangle on the grid. Remember, frequency density always goes on the y-axis, and we need to find the area of the inside. So the area, frequency density, is basically length times width. Okay, so now if I rub that out, we've got our formula here for histograms. So I need to find out the value of FD. So I'm going to write FD equals, now I've got the times time here, so the inverse of that is to divide. So then I'm going to end up with frequency divided by time. And here is the formula that I need to use here. So what I'm going to do is I'm going to write another section here, so frequency density, and then do all of my calculations. Okay, so using the calculator. Now what's very important is I use the the width for the time, not the actual time values. So, because if you remember when I said here we draw a rectangle, it's the width here that we need to use, not the actual times. Okay, so if we look at the class width here, 0 to 20, well that's 20, 20 to 60, that's 40, 60 to 120, that's 60, and then 120 to 200, that's 80. So now what I can do to work out the frequency density for the first one is its frequency divided by time. So if I write 42 divided by 20, 156 divided by 40, 84 divided by 60, and 64 divided by 80. So if I work all of those out, I end up with 2.1, 3.9, 1.4, and 0.8. Now, in terms of scaling, I look at the largest value for frequency density, and I look at my axes. So I can go 2, 3, 4, 5. So I could go in ones. So 1, 2, 3, 4, and 5. And then I could plot. So for my 0 to 20, I'm going to go to 2.1. So that is going to be here. So this is 0 to 20. And then plot down. That's this done. I'm then going to go from 20 to 60, so up to 60, and that goes to a height of 3.9. So that's to here, and that is to a width of 60. Okay, that's that done. 60 to 120 of 1.4, so 1.4 being here. That's that done. And 120 to 200 at 0.8, so that is here. And that is the histogram complete. So like I said, tip for the histogram, remember the formula, you don't really need to. Draw a rectangle onto the box, remember frequency density is always on the y-axis, and then from that point you can derive the formula. Sometimes you'll be given the frequency density and you'll need to find the frequency and so on. So you may need to use this formula in different ways. So please make sure, 1, you can remember it, how we just did it, and 2, you know how to rearrange equations. Right, for question 16, here is the part of a speed time graph for a car. Work out the acceleration of the car during the first 20 seconds. So we've got a speed time graph. The acceleration is going to be the gradient. So we need to find the first 20 seconds, and then we can draw our triangle, like so. We then remember m is equal to y over x, and then we can fill these in. So m equals, so y being the y, or the height, so we've got 15 here, and then we've got x value of 20. So it's 15 over 20. And putting that into our calculator, we get an acceleration of 0.75 meters per second squared. Right, now for the second part. When the car has reached a speed of 15 meters per second, it moves at this constant speed for 15 seconds. Show this information on a graph. So, car is going up, accelerating, it reaches 15, which is here, and then it goes for 15 seconds. So we're at 20, so that's going to push us to 35. So that means we should have a nice straight line if you're using a ruler up until this point here. Now, part C, work out the total distance travelled by the car in the first 10 seconds. So we find where the 10 seconds is, It says the first 10 seconds, so we're correct, got the correct one, and we can write the number 1 here. Now, we know that we have speed equals distance over time. So if we were to rearrange that for distance, we'd have distance equals speed times time. Okay. Now, the issue we've got here is that we are not running at a constant speed, it's accelerating as time goes on. What you need to remember is the area of a speed time graph will give us the distance covered. So, in other words, how do we find the area of that triangle there? So for shape 1, you can sketch the triangle down here if you like. We have a base of 10 and we have a height of 7.5. So the area of a triangle is half times base times height. So we end up with half times 10 times 7.5. When we put all of that into a calculator, you get 37.5 meters. So that's the total distance covered by the car in the first 10 seconds. So you need to remember the area underneath a speed time graph will give you the distance covered. Let's say, for example, this question asks you to find it for the entire journey. So up until this point here, you would have this larger triangle. You have to break it down to sections, this larger triangle, and then this rectangle section here. Okay, but in this case, it only asks for the first 10 seconds. So we only had that small triangle that I initially completed. Okay, question 17. Show that these two sets of brackets equal 31 minus 9 root 2. Show each stage you're working. So this is for 3 marks. So we got 5 minus root 8, open bracket 7 plus root 2. So for 3 marks, we do not want to mess this up. So 2 brackets, we should be thinking FOIL. Let's do this now. So 5 times 7, 35. Then the outside, so plus 5 root 2. And the inside, minus 7 root 8. And then the last, minus root 16. So let's just do the following. 35 plus 5 root 2 minus 7 root 8 minus 4. So one more step just to clear the 4 up. If I do 35 take away 4, that's going to leave me with 31. Then I've got my plus 5 root 2 minus 7 root 8. So you should be able to see this 31 is already linking with this section here. Okay, it does say show each stage you're working, so that's why I'm breaking it down quite a bit. So now we need to deal with the surds. Okay, so I've got 5 root 2 take away 7 root 8. Now if you do enough of these, you should be able to see that there is a way that we can link the root 2 and the root 8. So what I'm going to do here is I'm going to, just to one side, make the root 8 like so, and I'm going to do a factor tree. So root 8 I can write as root 2 times root 4. Now I know from this I've got root 2, and this can be made as, so I can write something like this. Root 8 is root 2 times root 4. Well, we know that root 4 is 2, so now I can simplify that to 2 root 2. So what I can do now is I can bring this back over here. So I'm going to rewrite a line again. 31 plus 5 root 2 minus 7. Now instead of root 8, I'm going to write times 2 root 2. And again, another line, 31 plus 5 root 2. Now, minus 7 times 2 will give us a minus 14. And then we can have 14 root 2. Now, I've got my number here still, the 31. Now, I've got these two as root 2. So now I can do 5 take away 14, and 5 take away 14 is going to give me negative 9, which leaves me with negative 9 root 2. So this right here matches exactly with this here. Okay, so it's a bit like terms with algebra. You must make sure you have the same surd before you can start adding and subtracting. Do not forget this factor tree to kind of split it down. And there's not really any kind of technique to it. It's just numbers that you know for sure. You can get rid of the square root. So root 4 quite easily became 2. You mustn't remember to, you mustn't forget to put the 7 back in. Okay, it's quite easy to go from this 7 root 8 and then just write minus 2 root 2. Okay, and you could quite easily forget this step here, the minus 7 times 2. But with the show that questions, you're seeing the answer already. So if you've got a bit of a weird answer here and you manage to get this, then maybe go back, double check that you've done the factor tree correct, and then you can kind of work from there. Okay, given that c is a prime number, rationalize the denominator of 3c take away root c all over root c and simplify. So we got 3c take away root c over root c. If we remember rationalising the denominator, we times by root c over root c. So going across, we're going to end up with root c times 3c minus root c over root c times root c. So let me just deal with the bottom first. So root c times root c, well that's, technically speaking, that's c to the half times c to the half. And then remember with indices, we are multiplying, adding, so that's technically c to the 1. So all we can say here is that this becomes c. And then of course we've got c to the half, or square root of c, times 3c. So two things that we can do. We can either make it like this, 3c root c, and then do take away c, because that's exactly what happened at the bottom. We've got root c times negative root c, so it will just give us c. And then we can look at factoring out a c from the top there. So I've got 3c root c minus c. I can pull a c out, open a bracket, and I can have 3 root c minus 1 all over c. And now because these are products, so what that means is we can multiply them. So it's c times the entire bracket divided by this c here. We can cancel these two c's. So our most simplest version is 3 root c take away 1. Okay, now let me just make this clear. If this was c plus 3 root c negative 1 over c, you cannot cancel out like that. Okay, so this is not a case of wherever you see something at the top and the bottom, you can just start cancelling them out and crossing everything out. You have to make sure that they are a product, or that they're in a multiplication form, and they are not adding or subtracting. Just be very careful with that. This is out of 2 marks, so you'd probably get 1 mark if you could get up to this stage here. Okay, question 18. So we've got two functions, f of x and g of x. Express the composite functions gf in the form gf of x. So we've got f of x as 2x squared plus 1, and then we have g of x as 2x over x minus 1. Now we need to form it as the g of f of x. So what that means is we get our g of x function, which is 2x over x minus 1, and we need to put the f of x inside the g of x function. So what that means is everywhere you see x in the g of x, you put the value of f of x. So let me explain, or let me show you. G of x is 2. Now, open bracket, and we put in the f of x value wherever we see x. So that's 2x squared plus 1, close the bracket, over, and this is x minus 1, so I'm going to put in 2x squared plus 1 minus 1. So if you look here, that's this value right here, and here, well, that's this value right here. Right, so now if we multiply that out, we end up with 4x squared plus 2 over 2x squared plus 1 minus 1. Well, the plus 1 and minus 1 would obviously cancel, so we just rub that out here and then just write the 2x squared. This could then simplify to 4x squared over 2x squared plus 2 over 2x squared. So what I've done here is split the fraction, and the reason for the split is because of this plus sign here. And then to simplify, I could do this. So 2x squared goes into 4x squared twice, so 2 plus, and then we've got the 2 and the 2, which will cancel out to 1 over x squared. So this would be our final answer. Part B, express the inverse function g to the negative 1 in the form of g to the negative 1 x. So I get my g of x function, so g of x equals 2x over x minus 1. I then put, instead of g of x, y, so y equals 2x over x minus 1. And now what I do is I switch the value for y with x and the x with y. So this then becomes x equals 2y over y minus 1. Now I need to do some manipulation to solve for y, or make y the subject. Okay, so this is then going to become, well, let me just keep that down there for now, y minus 1 and the x, so that's from the x there, is 2y. Now I haven't just got, I can't divide by 2 because I've got this y here, so I need to expand this before I can start doing that. So if I move that up here, I end up with xy minus x equals 2y. And now to get y on the same side, what I'm going to do is leave this as xy here. I'm going to pull 2y across, so minus 2y. And then going to put the x on the right hand side, so that becomes a plus x. Now I can factorize the y, so y, open bracket, x minus 2, close bracket, equals x. And to get y by itself now, I can write y equals x over x minus 2. And that's your final answer. So when you're doing inverse function, find out what the function is, write it, g of x, z of x, p of x, wherever it may be, then write the common y equals 2x, for example in this one, over x minus 1, switch every x you see with y and every y you see with x, and then you need to rearrange for y in this case. Okay, number 19, show that x squared plus 3x equals 5 can be rearranged to give x equals 5 over x plus 3. So there's a bit of factoring that we need to do. You've got x squared plus 3x equals 5. Well, we can see that x is common in both terms, so I can factor the x out. That's going to be x plus 3 equals 5. And then we need to show this. So in order to do that, we just need to get rid of this brackets here. So we end up with x equals 5 over x plus 3. Okay, because remember, two brackets, two terms in the bracket like that means to multiply. So this right here, we are dividing by that entire bracket on both both sides. So it's not too bad for 2 marks. Part B, use the iteration formula xn plus 1 equals 5 over x to the n plus 1 with x0 equaling to 1 to find the solution for the equation x squared plus 3x equals 5 to 1 decimal place. So using this iteration formula, we're going to start off with x to the 1. So let's look at this quickly. So we've got here, you can see this formula xn plus 1. So I'm looking at x to the 1. So technically that means I've got x, let me just fully write this out, x to the n plus 1 equals 5 over x to the n plus 3. So wherever I see, let me just write this in a different colour, try and make it really obvious. Wherever I see x to the n, I put in x to the n. So in order for me to get x to the 1, that's going to be x to the 0 plus 1. So x0 plus 1, that's going to give me x to the 1, equals 5 over x0 plus 3. So that happens to be, like it says here, x to the 0 is 1. So then I have x to the 1 equals 5 over 1 plus 3. So x to the 1 is 5 over 4. To x to the 1 is 1.25. So then I need to use all my previous answers to find out the following. So I'm not going to write all of that for every single one, but for x2 example, I would write 5 over 1.25 plus 3. Now if I do that using the answer function in the calculator, I'll end up getting 5 over answer, I get 1.176470588 by x2. So now we're going to keep on doing this until we get a solution to 1 decimal place. So now for x3, so if I write x3 here, we're going to have 5 over the answer from the previous, from the x2, plus 3. So now using my calculator, if I use the answer function, I'm going to get my answer here, which happens to be x3 is 1.197183099, and if I do that again using the answer function for x4, I get 1.1912751168. So what you should be able to see here is that these numbers here have stayed the same. It's only the last parts that have changed. So this does say that we need to get a suitable solution to 1 decimal place. Well, that would be 1 place after the decimal, so we'd be looking at this number here. If I look to the right, that number is 9, so our solution would be 1.2. So remember, iteration is we keep on doing a particular task in order to find something. So it's basically like trial and improvement, or trial and error, however you like to say it, trial and improvement. It's a way to find a solution to certain equations. So when it stays the same, apart from a very few minority, this said to 1 decimal place, we saw that the number was staying the same, so we could stop there. Okay, and finally for the last question, we got solve the equation 3 over x plus 2 plus 4 over x minus 3 equals 2. So we've got quite a big space here, so there's going to be quite a lot of work here, and it does say show the working clearly. So first thing that we need to do is we need to make sure all of the denominators are the same. So this number here is over 1, and of course the 3 is over the x plus 2, and the 4 is over the x minus 3. So what I want to do is I would like to do a slightly big fraction here, the plus sign, big fraction here, and then a big fraction here. So I'm going to write the original, which is x plus 2, and then I'm going to add the x minus 3 as well. I'm then going to make that the same for all 3 fractions here. Okay, now I'm going to write the original, what was here, and if I look at the first one, I've got x plus 2 as my first fraction. So what I want to do is I want to multiply by what I brought in. So in this case it's going to be x minus 3. If I then move on to the second fraction, I'm going to write 4. I started off with x minus 3, so I would like to do x plus 2. And then finally here I started with the number 2, and I didn't have either, so I'm going to write x plus 2, x minus 3. And now that I've done that, I've made all of the fractions equal. I can then expand out from this point, and I'll be able to manipulate them. Now, just for those of you that may want to see why this is possible, I haven't actually changed the equation that we're given. Okay, now I'll show you why. These are all multiples, so all products, so I can cancel out. So what you should be able to see is that if I cancel this out, I cancel that, and I end up with what I had in the beginning. If I cancel this out with this, I end up with what I had at the beginning. And if I cancel this x plus 2 with this x plus 2, and this x minus 3, and this x minus 3, that's exactly what I had in the beginning. So all I've done is manipulate it. I haven't changed it as such. So now that I've got this, what I can do is expand. So I'm going to end up with 3x minus 9 plus 4x plus 8 equals 2, and then I'm going to have to expand these two brackets here. So for now I'm going to leave the 2 to one side, and I'm going to do FOIL. So FOIL, just put that here. Right, so x times x is going to give me x squared, so let's not forget there's a bracket here. Then the outsides minus 3x, and then the insides plus 2x, and then the last of each bracket, which will give me minus 6. So writing this all out again, 3x minus 9 plus 4x plus 8 equals 2, open bracket. Simplifying this down now, x squared minus 3 plus 2 will give me minus x minus 6. Okay, so again, writing this clearly again, 3x minus 9 plus 4x plus 8 equals, now multiply and expand this out, so 2x squared minus 2x minus 12. Now you may have noticed I haven't, touched this section here. You do not want to do everything at once. Okay, it says show clear algebraic working. Do not mess this up by trying to do the left and right side at the same time. Take your time, there is no rush. As you can see here, there's a whole A4 page that you're given in the exam for this last question, and it's 5 marks, so don't mess it up by rushing. So now on the left hand side, two things you would have noticed. One, I have not touched it, so not simplified it, and two, you'll notice that I've not written the denominators of each fraction. Okay, so basically I can forget about them now because they're all the same and just deal with the numerators. So if I look at this now, I can simplify this. So 3x plus 4x, that's going to give me 7x, minus 9 plus 8 is going to give me minus 1. So I end up with 2x squared minus 2x minus 12. And now I can simplify this. So let's just deal with the minus 1 first. So 2x squared minus 2x. This was a negative 1, so I'm adding 1. So negative 12 plus 1. Again, calculator paper, if you're not sure, just type it in. Minus 12 plus 1, minus 11. And then we need to make this 0 here. So 2x squared. Now, we've got a positive 7x here, take away 7x. So minus 2, take away 7x is going to give us negative 9x, and that will be, therefore, negative 11. Now, let me just clear this up, because it does say that we need to solve. So by looking at this equation, we should be able to see that it's quadratic, and that we're going to need to solve it. So I'm moving this to the left-hand side now. just to free up some space. We need to solve this quadratic here, so we've got 2x squared minus 9x minus 11. So we've got a calculator paper, so we can do the formula. So a, b, and c, if we remember, ax squared plus bx plus c is the generic template for a quadratic. We've got a as positive 2, b as negative 9, and c as negative 11. Remembering the quadratic formula, minus b plus or minus the root of b squared minus 4ac all over 2a. So remember there are two solutions, so 1 plus 1 minus. So I'm going to do one solution here. So this will be a minus b plus. Again, writing it all out. And here a minus b minus the root of b squared minus 4ac all over 2a. That's very important. You do not forget to use the brackets here. So minus, then whatever b is, so it's negative 9, plus the root of negative 9 squared minus 4 times a times c. Again, do not forget the brackets. All over 2 times a, which is 2. Doing the same here now. Just split this up. Same here, so minus b, which is minus 9, minus, that's a plus, minus the root of minus 9 squared minus 4 times 2 times minus 11 all over 2 times 2. Now putting that into the calculator, not forgetting your brackets. You get 11 over 2, which is 5.5, and for the negative you get negative 1. So there are your two solutions there.